Venn diagrams. We've got a few things we need to define first. You don't need to copy everything out here that you see, but I will highlight the important things, the things that really should be made note of in your Cornell notes. So you firstly see sample space. You should have heard of this before, because with probability, sample space is a list. It's a list of all possible outcomes, and you will see sample space when dealing with Venn diagrams in probability as well. Sample space is most commonly called capital S, but sometimes these other funny symbols get used as well. The most common one is either S or U. Okay, now the U stands for universal set. It means the same thing as the sample space, so let's make a note of that. So sample space or the universal set. Okay, so be aware that they mean the same thing. Alright, next we have a subset. You might have heard the term subset used in everyday language, or you might not have. However, it's an important word in Venn diagrams. Subset has that symbol. It looks like a C, but it's been elongated and sort of flattened out, and so that's your symbol which you can use instead of using the word subset. Should make a note of that. And a subset fits inside another set. So a subset of TV viewers is people who watch Netflix. So if we had a set, let's say this is the set of all people who watch TV, which would be a big set. The subset people who watch Netflix would sit inside of that. So it's a smaller set that fits inside a bigger set. So a subset is for example, another example there using a mathematical example. They've got written there A is the subset of prime numbers. You can probably see that there. A is the subset of prime numbers less than or equal to 10, which is a subset of all the integers less than 10. So in other words, if you've got this list here, that's all the integers from less than 10 wouldn't include the last one, I suppose, but all the integers less than 10 would be that set. I'd close the gate there, and a subset of that would be all the prime numbers, which is a smaller set, because that's a prime, that's a prime, that's a prime, that's a prime. Okay, and it's a smaller set that fits in the bigger set. Okay, what should also be familiar on the next line is this idea of the complement, because we've seen that in our introduction to probability. Complement means not, and we've seen that before in probability, and it's got one of the little notations is for set A, call it A dash. Alright, and you can see a diagram of that here. For this set up here, okay, things that are only in A, the prime numbers are listed there, and things that are in this group from 1 through to 10 are in the universal set. So things that are only in A are the prime numbers, that's in there. In everything inside the rectangle would be this universal set, or the sample space, and stuff that's not in A will go in this dark region here. You can see it's labelled A complement or not A. Another thing you need to know is that symbol means element of, so it's shorthand. So if we went 5, that symbol A, it means 5 is an element of the set A. And if you look at the set A, yes, 5 is an element there. It's one of the little numbers that goes in there. The next symbol is a 0 for cross through it, means the null set. Now the null set is an empty set. So you can have a set with nothing in it, and it's called the null set. Next thing is very important. So I'm going to change colour now. If we got set A, little n of A is the number of elements in A. So the number of things that are in A, I guess. If you look back up here, there's A, and it has 1, 2, 3, 4 things in it, 4 elements. So the number of elements that A has in it is 4. That's very important. Next, a Venn diagram can be used to illustrate how different subsets in the sample space are grouped. Now be aware that we are treating Venn diagrams in a particular way here, and sometimes other books or other resources treat Venn diagrams a little bit differently. But what we're going to do is look at how they're grouped and the numbers of elements that go into each set, not the elements themselves. So set A, if set A from above, it's all coloured in now, but it's that same set A there. If we write that down again here, and set B is this, if we're given these two sets, there's some things that are in both set A and B. Can you see them? Well, 3 is, 5 is, 7 is. 3, 5 and 7 are the elements that are common to both, and we would call that the intersection. So A intersection B are the things that's in both, and the set A intersection B is 3, 5 and 7. So we write A intersection B, that's what that curvy N intersection. So think of N intersection, and you get that N symbol, is 3, 5 and 7. Now how many elements is that? 1, 2, 3. That's why 3 goes there. Now the zone in between the two sets where there's the overlap is the intersection. If you've got a road, alright, and there's a crossroads there, there's the intersection where one overlaps the other. And sets are the same, so it's got a bit of A and a bit of B. In fact, it's the common ground between A and B. Now, how many things are in A that are not in B? Well, 2 is, and that's it. So there's one element that's in A but not in B. How many elements are in B but not in A? This one and that one. So that's 2 elements, and that's why there's a 2 there. Alright, now not everything in the original set was there, because we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, we've got, if you look at the camera there, well, my image, we've got 1 is accounted for, 2 is accounted for, but what about 3, yes, 4? That's one thing that's not in either set. 5 is, 6, that's 2, 7 is, 8, that's 3, 9 is, 10 is not. So there's 4 things from the original set from 1 to 10 that are in the universal set, but they're not in A or B or A intersection B. So those go in the outside zone there. Okay, so you might need to rewind this video because there's a lot of detail there. If you do need to rewind the video, please take responsibility and do that. A couple more things now. There's this symbol here called union. A union B means A or B. So it includes, the union of A and B includes the elements in either A or B. So really that's everything across here. So it let me just rub that earlier bit out there. So everything that's in this zone here, it's in all of these things here. Any element that's in that, alright, it's in A or B or in both. So going back up there, we will look at all the elements. So you'd have 1, 2, 3, yep, 4's not in either, that's why it's down in that one. 5, yep, 6 is not, so it'll go as another one there. 7 is, 8's not, 9 is. Alright, so they're all in there, 10's not. So all the ones that are in this zone here, in A or B or A intersection B, go there. A, things in just A, are only in A, but they're not in anywhere else. So that'll just be this one here. Okay, so let me get a better colour. So things that are just in A will be just in this bit here, and that is like this number 2 here, that one. So it is only in A, but it's not in the intersection, and it's not only in B, it's just in A. So the set A only is 2. Quick example. Alright, now when you're reading these, make sure you read them carefully and don't panic if you don't understand it first time. So a number is chosen from a set of positive integers. Now, set of positive integers. Integers, you might remember, are whole numbers, and they also include 0, but this is positive integers, so it has to be bigger than 0. So the first whole number bigger than 0 is 1, 2, so it'll go from 1, this one says 1 through to 8, okay, so it's 1, 2, 3, 4, 5, 6, 7, 8, da 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 da, and you can actually see that down here. I've just saved a bit of time, I've pasted that answer in down here. So that's actually the sample space, or the universal set. So it's everything that we're considering, everything that we're interested in. Okay, don't worry about stuff that's outside of that. So list the set, the sample space would be this just down here. Next, if we've got set A, we need to read on. If A is the set of odd numbers between 1 and 8, alright, well, that would mean A would be 1, 3, 5, and 7. Set B is a set of prime numbers between 1 and 8. Prime numbers between 1 and 8. Remember, 2 is a prime number, it's the only even prime. 2, 3, 5, 7. Prime numbers have only themselves and 1. So we've done those 3. Draw a Venn diagram. Okay, here we go. So we need to consider the universal set. Okay, so that's the universal set, or the sample space. You could even put a little U there if you like. And everything that goes in there is basically from this set here. Okay, everything from there will go in there and nothing else, and nothing can be left out. So the Venn diagram, we need to look at A and B. So is there any overlap is the first thing I look at. Yep, 5 and 7 and 3 are in both A and B, aren't they? So there's going to be plenty of overlap. So we've got 2 circles, and basically how many things are in the intersection? 3, 5 and 7 are, so there's 3 things there. How many things are in A and not in the intersection? Just 1. This element here, there's 1 of those. The number is 1. We look at the cardinal numbers, like how many are there? There's 1. How many are in B that are not in the other parts? Well, 2. 2's in B only, so that's a single number. So that's our Venn diagram. How many numbers have we not accounted for? We haven't accounted for the number 4. We haven't accounted for the number 6. We haven't accounted for the number 8. So there's 1, 2, 3 more numbers there. That's our Venn diagram. Okay, next we've got to list the sets A intersection B. That's where we have common ground or overlap between the two of them. Let me clean this up a bit. And we've got basically what are the 3 things, the 3 elements that go in here. Well, we've got to write that down. So A intersection B. Alright, bring the cursor down here. So A intersection B is, well, what's in both? 3, 5 and 7 are in both. So we go 3, 5 and 7. A union B is basically anything that's not in there. Okay, so it's in stuff, that's in one of those, A or B or both. So it's the stuff that is in anywhere in here. Okay, that's the union. So A union B is the next one. So we've got A union B. Well, what are they? It's everything. Now we don't repeat things. So don't repeat the 3s, 5s and 7s. So we've got 1, we've got 2, we've got 3, we've got 5, we've got 7. We only put them down once each. Okay, and that should make sense because we've got 1 plus 3 plus 1 is 5. And we have 1, 2, 3, 4, 5 there. Okay, we'll leave the rest for the next video, and we'll see you in class where we can practice this.